Here we go, part 3 of the midterm. Number 11. I actually recorded it on the last video and then had to cut it off because I went over 15 minutes. So here's stuff already written. We did a little bit of graphing with the tangent and the secant and whatnot. The shifts and the stuff are the same as they were with sines and cosines. But even if you didn't have a grasp of that, you do know something about the tangent. You know that the tangent is sine x over cosine x. So the tangent of 2x would be sine 2x over cosine 2x. And to ask where are the vertical asymptotes is to say, when are you trying to divide by 0? When is the cosine of 2x equals 0? Well, I know graphs of cosine, and then I know what the 2 does, right? So here's the graph of cosine, one cycle between 0 and pi. This is pi over 2. It would be 0, sorry, 2 pi cut in half is pi, cut in half again is pi over 2. So pi over 2 and 3 pi over 2. So a half pi and 1.5 pi. That's when the cosine would be 0. When you squeeze that down by a factor of 2 because of that 2 right there, then you got 2 cycles between 0 and 2 pi. So one cycle from 0 to pi. This would be pi over 2. Half of that would be pi over 4. So the places where the cosine of 2x is equal to 0 would be at pi over 4 and 3 pi over 4 and 5 pi over 4, 7 pi over 4, all the odd pi over 4s. So that's where the vertical asymptotes are going to be. Likewise, if you did have an idea what the graph looked like, the 4 shifts it up. That's not going to change where vertical asymptotes are. The 3 scales it vertically. That doesn't change where the vertical asymptotes are. The only thing that changes is that 2. That 2 squeezes everything in by a factor of 2. So where the original tangent curve has a vertical asymptote at pi over 2, when you squeeze it in, it becomes a pi over 4. Right? And the 3 pi over 2 gets squeezed into 3 pi over 4. Anyway, explain that to me. Simplify the expression. Yeah, this was just basic identities. We did some work with basic identities, recognizing, for instance, that the secant of x is 1 over the sine of x. And then there are people that need to explain to me how to do algebra. It's not the trig they did wrong. It's just that they did some really goofy algebra stuff, trying to get common denominators, or I have no idea what. But there's a distributive property here that you just distribute this times that. Right? So you got sine x times 1 over sine x minus sine x times sine x. So there's a little bit of an interruption there. So now I got sine x times 1 over sine x. I got a number times its own reciprocal. That's just 1. Essentially the sine x's cancel out. And the sine x times sine x is, we write it as sine squared x. Right? You take the sine of x and then you square it. Essentially you multiply sine x times itself. Now some people left it like this. I mean, yeah, that's certainly more simple than it was. But there's one more step you can do, because 1 minus sine squared x is cosine squared x. Oops, again, I wasn't supposed to do the whole thing. But there's a lot of different things that people did wrong here. If it was algebra that you did wrong, then figure it. Then talk about that to me. Tell me what it was, and what did you distribute wrong? Did you? I mean, there's one person that took the sine x times sine x and wrote it as 2 sine x. Right? It's like what's x times x? Is x times x 2x? No. It's x squared. That the notation of 2x means x plus x. The notation of x squared means x times x. So talk about that. So talk about the notation that you misunderstood or something. Anyway, explain what you did wrong, no matter what it was. Here we go. 13. Given triangle ABC. ABC with angle A equals 15 degrees and angle B equals 40 degrees, and then side C is 500. So side C is opposite here, so this is 500. This is A and this is B. It says to find side A. So of each angle and its opposite, I got the angle but not the side, I've got the angle but not the side, I've got not the angle, and I do have the side. I need 2 of something. But I got 2 angles, so I can use 180 minus those. So angle C is going to be 180 minus 15 minus 40, which is 125. Is that right? Or 115, 55, 125. So this is 125. Now I can use the law of sines, right? Because now I've got a over sine of 15 degrees. This one, that one is 500 over the sine of 125 degrees. And then solve for a. There were some people that tried to do this like a right angle, like there's a right triangle in here or somewhere, but it's not. There's no 90-degree angles. So you got to use law of sines. Number 14. Number 14. Again, I got triangle ABC. Angle A is 30 degrees. Side B, so opposite of B, is 50. And side C, opposite of C, is 40. And it says find angle B. Find angle B. Well, the information I have here is side angle side. Law of sines, again, each pair, just like up on the last one, for each angle on the opposite side, I know one thing but not the other. I know the angle but not the side. I know the side but not the angle. The advantage I had up above was that I knew two of the angles, so I could find the third angle. Now I only know one of the angles, so I can't find the other two right off the bat. So what I got to do is I got to use the sides, and in particular, I can find side A by the law of cosines. A squared equals 40 squared plus 50 squared minus 2 times 40 times 50 times the cosine of that angle there, 30 degrees. Okay, so you can find A by taking the square root. Right, square root of that whole thing. Once you have A, then you've got side A and angle A, and you can start using the law of sines. Okay. Now, one thing that went wrong for a lot of people is they gave an answer of like 82 point something, 82.57 or something like that. And I didn't mark anything wrong other than the answer's wrong minus 1. Right? Well, the problem is when you use the law of sines to find an angle, you're in the ambiguous case. And you got to know, is this possibly going to be bigger than 90 or not? Because when you use an inverse sine to find the angle, you'll never get an angle bigger than 90, even if the angle needs to be bigger than 90. So the thing is here, it turns out that when you find A, it's like 25 point something or 24 point something, I don't remember. But it's smaller than either of these other two. So 30 is the smallest angle. 50 is the biggest side, which means angle B is the biggest angle. It's the only one that might be bigger than 90 degrees. So using the law of sines to find angle B is the wrong thing to do because you don't know whether it's going to be right or not. Instead, use the law of sines to find angle C. I know that angle C is not the biggest angle because it's across from the side that's not the biggest side. So there's no way that angle C could be bigger than 90 degrees, and the law of sines will get it right. Then do 180 minus this minus that to figure out what B is, and you'll find that actually B is bigger than 90 degrees. It's like 97. So this is not the ambiguous case because the information determines only one triangle. But when you use the law of sines to find an angle, you're setting yourself in the ambiguous case, even if you shouldn't be in it, right? Which is why I say use the law of sines to find the smaller angle first, and then come back to the bigger one. Now, there are some people who just use the law of cosines to find angle B. They use the 50 squared equals 40 squared plus A squared minus 40 times A times the cosine of B, and they end up solving for B with an inverse cosine. Now, the inverse cosine will get angles bigger than 90. If the input to the inverse cosine is less than 0, then it'll give you an angle that's in the second quadrant, so something that's bigger than 90 degrees. So anyway, I would use the law of sines to find angle C, and then once you've got C, you can just subtract to get B. Okay. Is that it? Oh, that's the last one. Okay. So again, Write me a report by next Monday that has all your mistakes as to why they're wrong and then how to do those problems correctly. I will take a look through them. If you have sufficiently convinced me that you can do these problems, you know how to do them, you know why what you did was wrong, then I will essentially give you the difference between your score and a perfect score, right? I average your score with 100 and give you that score. Okay. You can do this. I know you can do this. It's just a matter of looking back through it again and figuring out all those mistakes. So.